are already making great use of the ability to add 3D component bodies and import step files into their PCB designs for real-time viewing and clearance checking of components and enclosures. And an additional benefit of this capability is the ability to actually use the 3D model of the component and its features to guide creation of the PCB footprint in the PCB library. As an example of this, I'm going to show how to build this connector in a PCB library. This connector is a Molex Microfit 3 series, and fortunately, Molex provide detailed datasheets and even a 3D step file for download from their website. So I'll start by downloading the 3D step file and saving it to my library source folder. Then I'll open the PDF drawing of the connector. This datasheet contains all the necessary pin numbering and dimensions for making the PCB footprint for this connector series. This area shows the details for the PCB hole pattern, and this area shows the mechanical dimensions. The part number of the connector I'm using is a 43045-1012, which is the 10-pin version of this connector. Also note that the pin numbers begin here with pin 1 and will end at 10 over here, and there are 2 mounting boss holes needed here and here. Now, I could follow these dimensions to position those, but since I have the manufacturer's 3D model as well, I'm going to use those to guide the placement of the holes on the board. But first, I'll start by creating a new blank component in my PCBlib, and then by placing the first pad for the connector's pins from Place, Pad. I'll hit Tab to bring up the pad properties and set this pad to have a 40mm hole as dimensioned in the datasheet. I'll make this a rounded rectangle for a nice solder fillet around the square pins of the connector, with a 2:1 aspect ratio for strong mechanical support of the connector. Since this is for pin 1 of the component, I'll make sure the designator is set to 1. After placing the first pad over the origin, I'll select it and use Ctrl-X to cut this to the library editor clipboard, and then go into Edit, Paste Special, and use Paste Array to place 5 matching pads on the footprint, setting their spacing to 3mm horizontally according to the dimensions on the datasheet. I'll use Paste Array again to place pins 6 through 10. The pin numbering here is back to front along the X-axis, so I'll select all these pins and move them with the mouse using the X key to flip them along the X-axis. Now the horizontal spacing is exactly correct, but we may need to adjust these pads along the Y-axis to get them spaced at exactly 3mm. But here's where we can start to make use of the 3D model downloaded from the manufacturer's website. I've already downloaded and extracted the 3D step file for this connector, so I'll go ahead and use Place, 3D Body, and set it to Generic Step Model and browse to the step file from Embed Step Model. Since I'm in 2D mode, the step model is shown as a simple body outline. I'm going to click to place it just above the pads and hit Cancel when the 3D Body dialog reappears. Next, I'll go into 3D mode by hitting the 3 key. In 3D mode, I'm using the same mouse gestures to zoom and pan, only with the Shift key down I can also rotate using the right mouse button. With the connector positioned like this, it's easy for me to place snap points on the pins. You can also see clearly the 2 mounting bosses I mentioned earlier, here and here. First, I'm going to place a snap point in the middle of pin 1 on the connector to align the pins with the pad holes. To do this, I'll use Tools, 3D Body Placement, Add Snap Points from Vertices. The snap point cursor prompts me to select the 3D body of interest first, and then begin snapping to vertices on the 3D model. Since I want the exact center of the pin, I'll press spacebar and click on 2 diagonally opposite vertices. This puts a snap point in between the 2 corner vertices, which happens to be the center of the pin. I'm going to add a similar snap point to the corresponding pin on the second row too. And while I'm at it, I want to add the snap points to the center of the 2 mounting bosses. That's going to enable me to add accurately positioned holes for these afterwards. Notice that on these circular bosses, the snap points can be easily added to the center of them, which is exactly what I need. Now I can clearly see those are in the right places, so I'll press 2 to go back into 2D mode. The snap points are now available also in 2D mode, so when I click and drag the mouse near this one, it's easier to snap it to the center of pin 1. But pressing 3 again reveals that the 3D body is not set to the correct height, So I'll go to Tools, 3D Body Placement, Set Body Height, and choose any vertex which is going to be at the PCB surface. Then in the pop-up, select Board Surface and hit OK. Now we see that the height is correct. I'll go back into 2D mode again. I can see here that I need to move the second row of pads into alignment with the 3D models pins as well, so I'll select these pads with the mouse. Then clicking and holding the left mouse button as close as possible to the middle of pad number 6 will grab them and also snap the cursor to the center of that pad. That's very convenient because now I can move these under the mouse cursor to the pin 6 snap point I added to the 3D model previously. And I can tell when it's snapped to center because a small octagon appears, so I'll release the mouse button. Next, I need to place unplated 40mm holes for the two mounting bosses. I'll use Place Pad again, but this time I'll set the pad size to be 20mm and the hole to be 40, so there's no copper, and clear the plating option so there's no through plating specified either. I'll designate these holes with a non-numerical string, in this case MTB, so that those will not be linked to the PCB nets in any way. When I hit OK to continue placing these mounting boss pads, you can see that the snap point on the bosses are useful for precisely positioning these holes. The last step for me is I want to have an accurate silkscreen representation of the connector on the PCB. So I'll go back into 3D mode and place some snap points at strategic vertices of the 3D model. These form a guide which I can easily follow to draw the 2D outline of the connector on the top overlay layer. Now that I'm finished making this PCB component, I can remove all of the snap points on the 3D body so that they don't show up in the designs that will use this part. To do that, I'll go back into 3D mode with the 3 key and use Tools, 3D Body Placement, Remove Snap Points. Here I can just keep clicking until they all disappear because the mouse cursor snaps to each snap point automatically. So that's how you